Okay, this was one part of our lesson today, which is completing the square. And the question is, why do we even do this? And the reason is when we want to convert from standard form to vertex form. Okay, so let's do a quick little refresher. Standard form is, let's just write this down. Standard form, I'm hoping we know this by now, ax squared plus bx plus c. Vertex form, which we should know by now as well also, is ax minus h squared plus k. So, the thing that's a little bit different about this is that we are trying to get this to something squared, a binomial squared. And what that means is that it's a perfect square factoring. So let's just take a couple of examples of that. Here we have, so let's just call this example number 1. And what we are going to be doing is taking a look at a perfect square trinomial. All right. So if I have, let's say I have y is equal to, say I have x squared plus 6x plus 9. How does this factor? What multiplies to get a 9 and add up to a 6? It would be x plus 3 and x plus 3. How do we write that? We can write it as factors squared, as that x plus 3 times x plus 3, that's the same thing as squaring it. So this is what you have to be able to realize. Why? Because if you look at this and look at vertex form, that's what it has. So we have to understand what we are doing to get it to vertex form. Let's go ahead and do another one of these perfect squares. So I have y is equal to, let's say I have x squared minus 8x plus 16. What could that possibly be? Okay, so let's take a look at this. 16 factors are 1 and 16, 2 and 8, 4 and 4. I believe that's about it. So how can we get to a negative 8 with these? How about a 4 and a 4? That can get you to an 8. They have to be a negative 8. Those are both going to be negative. What else needs to be true? The negative 4 and the negative 4 need to multiply to that 16. Next thing's next. How do we write this as a squared? Like that. So, in order to make this vertex form, we're going to have to force this perfect square thing to happen, and then that will turn around and give us the other parts of the vertex form. All right, let's keep going. So, let's say I have, let's try this. We're going to do completing the square. And again, we are going from standard to vertex. All right, so let's say we have y is equal to x squared, let's say plus 10x minus 3. So you look at this and you go, does this factor? No, it doesn't factor, right? Because how can we have a negative 3 multiple and end up adding to a 10? Doesn't work. So again, we're converting this to vertex form. What does it have? It has that x minus h squared. We want to convert this. So we want to convert the factors to a perfect square trinomial. So in this case, we're just going to look at the 2 on the left. So here's what we're going to do. Here's what those little blanks are. I want to force this to be a perfect square trinomial. How do I figure that out? What's the perfect, what is 10 divided by 2 to get us that number that if we add and add, we'd get to 10? So we're looking at this. 10 divided by 2, which is 5, and we square it to get that number that goes there. What is it going to be? It's going to be 25. What do we have to do? I needed to correct this a little bit, you guys. This needs to be a minus right there. So if I am adding 25 to this trinomial, I need to subtract 25 from that. Why is that? It's basically a difference of 0. So now what do I need to write? I have y is equal. Let's factor this part. What is it? X plus 5 times x plus 5. Combine those two together, we get negative 28. So what does it really look like? Remember, this is the same thing as squared. Guess what, you guys? That is vertex form, right? Binomial squared, sometimes we have a coefficient in front and minus the 28. What's the vertex of this? Negative 5 and negative 28. All right, let's just try one more. Again, we have a trinomial that we're forcing into that perfect square trinomial situation to write it into vertex form. All right, let's try to do, how about negative, what should we use? 8x, let's say, plus 3. Okay, so we want to force this part to be the perfect square. Just the two terms in the front. How would I do this? Negative 8 divided by 2 gives me negative 4. If I square that, I get 16, right? Because this is going to be my perfect square trinomial. Why? Because when I turn around and factor that, I get x minus 4 and x minus 4. Oh, and don't forget here, you guys, if we added the 16, we need to subtract the 16. Because again, that's a difference of 0. So over here, we end up with a minus 13. The final way to write this is squaring those binomials, and that would be vertex form. What happens? What is the vertex? Remember, it's just that opposite and that k at the end. This is a 4, you guys. That kind of looks almost like an A. That is a 4. Okay, see you next time.